Hello guys. So in this video we're going to discuss about one of the most important techniques under integration, that is called integration by parts. And you will use this technique after A levels as well, if you get into science field. So that's why this method is very important, integration by parts. And before I get into details, I will explain why do we need a technique, a different technique. And integration by parts, the name comes from the technique, right? So what we do in the technique, right? So it's based on that. So this name given for that technique based on the technique, right? So why do we need integration by parts? So this is the reason. Now suppose we have integral like this. You have seen the basic integrals, integral of x dx, right? So let me make it more general, x to the power of n, whatever it is, one of the basic integrals. So what was the answer? The answer is x to the power of n plus 1, you add 1 to the index, then you divide by this, right? Divide by this plus an integration constant if this is indefinite integral. That means you don't have anything here. May udai ata mukut naththam integration indefinite integral ekak, you add a constant to it, arbitrary constant. Okay. Now what if we had this integral of sine of x dx? Integral of sine of x dx. That means by that they are asking you to find what function being differentiated produce sine x. What function being differentiated produce sine x? That would be cosine x. So when you differentiate cosine x, you get minus sine x. So to get the integral of sine x, it should be minus cosine of x plus c, right? So these are standard integrals that we have to memorize for the exam, right? So we have to memorize those standard integrals. There's a limit to that, limit to what we have to memorize, right? So we can't memorize all the integral out there in the universe, right? So we have to memorize certain integrals that are called standard integrals. Now what happens if we get a product like x to the power of n, or let me just say to be more specific, x, right? X times sine of x dx. What is this, right? This is different. You don't learn this under standard integrals because here you have a polynomial. This is a polynomial. The basic unit of a polynomial. See, this part is polynomial. Let me call it poly, right? Then this part is trigonometry. This part is trig. Comes from trigonometry, right? Which here you have a product of sine x with x, product of sine x with x, a product of two different functions. Now we don't learn this under standard integrals. Then how do we evaluate such integrals, right? How do we evaluate such integrals using standard integrals? That is why we need a different technique, right? That's why we need a technique, because it's not listed under standard integrals. So we need a technique to reduce this integral or evaluate this integral in terms of what we memorize under standard integrals, right? So that's the basic idea of integration by parts, right? So now we'll move on to the theory part and we'll learn how it was derived, and after that we'll move into examples, right? So integration by parts, the technique is based on the product rule, right? So integration is the reverse process of differentiation. So this integration by part technique is a result. It's not a direct result. So some sort of a direct result from differentiation of product of two functions. Because in the example I showed you, there was a product x into sine x, right? So what is the product rule? If you revise on the product rule, derivative of fx into g of x, this is a product of two different functions of x, then that is equivalent to one function multiplied by the derivative of the other function plus the function you just derived here multiplied by the derivative of the other function. Okay. Then integration is a reverse process. When you differentiate this, you get this one. Then if you integrate this side, g of x df of x dx, right? Then let's call this plus f of x dg of x dx dx. So notice here, this is the part you integrate with respect to x. So you have to add dx there. When you integrate this side, you should get the original function. The function on being differentiated, you get this. So the original function is this product, g of x. Right. Plus c. Now in this case, we are not going to add c. I will tell you why. Right. So let's not add c for now. Now here's the thing. I can break this into two parts. G of x df of x dx. Then I have to add dx here, right? Dx. Don't try to cut this off, right? Don't do that. Plus integral f of x dg by dx dx equal f of x g of x. Right. Now here we have two integrals. Let me make this a bit interesting. I'm going to take one of these integrals to the other side. So let me write it like this. Let me write this here because otherwise you would cut this. df of x dx into g of x dx. I'm going to leave this integral on left hand side. Then write this integral on the other side. So I'll bring this over to the right hand side. Then this becomes minus f of x dg of x dx by dx. Right. Now what do we have here? We have one integral on the left hand side. We have another integral on the right hand side. Notice that this integral is not equal to this one. There are two different integrals. Two different integrals, right? But they are interrelated. They are related by some relation, right? So this integral is related to this integral with this relation, right? So if you deduct this integral by this product, then you get this integral. So notice here, if you want to integrate this, and if you can't do that, instead you can integrate this integral and get the difference between these two. Those are two equivalent things, right? Suppose you can't integrate this one. If you can't do that, you can use this relationship to convert this integral into a new integral. Hopefully this integral is easy to integrate. That means it exists under standard integrals, or you will be able to do partial fraction decomposition, no substitution technique, which you will learn in the future. By doing so, you will be able to do this. So that is the idea. So idea of integration by parts is to convert, right? Convert the given integral into something that you can integrate, right? So this is the technique. This is the technique. Okay. Now it's easier to use this technique if you can memorize it. But sometimes when you get used to doing calculations, then you don't have to refer to this formula as it is. But it will be helpful if you can remember this. So write it down before you attempt the question. Now there's a simple way to write this. So integral df by dx into g dx is equal to f into g minus f into dg by dx. Right. So this is what we can use, because it takes a lot of time to write this down. So please write this down as well. Okay. Now you might be wondering why I didn't write the constant c here, because in this case you are going to convert one integral to another integral, right? So when you convert that integral, you will definitely add the integration by parts at the end of the result, right? To the last step or to the result, you will add an integration part, integration constant anyway, so you don't have to worry about adding integration constants there. So that's why we didn't add integration constant there. Right. So now we'll move into examples, and we'll discuss maybe 3 or 4 good examples, because you should know how to use this technique. In some examples, you will have to use this technique twice, right? Some examples twice or more than twice to get the final answer. Right. So this is how we are going to use this technique. Please pay attention and closely look at the details, right? So now we have a product. Now this is also a product. So you have to select the correct functions, right? To replace this function and this function. Here you have one function, you have another function. This is a product. You have to select them. Right. So if you come up with the correct selection, then your final integral would be easy to solve. If you got it wrong in the first place, your final integral will be much worse than the original integral, right? So I will give you a guide at the end of these examples, but until then, look at this. Now we have a product. Now what to choose? What do I choose for df by dx, right? X or sine of x, right? X or sine of x. Now look at this. If I choose x here, on the right hand side, I have to integrate this. Now see, on the right hand side you have f. df by dx goes to f. df by dx goes to f, which means, how do I get f? F being the original function. If I want to get f here, then I have to integrate this function. And what will happen to g function here? G will be differentiated here. G will be differentiated here. So I have to use my brain. If I use x here as df by dx, on the right hand side, x will be integrated. When you integrate x, it will be x squared by 2. Right? So here we would have x squared by 2. Then sine of x would be g, and g gets differentiated. When you differentiate sine x, you get cosine x. So in this integral, if you choose it wrong, you get x squared by 2 cos x dx. Now this is way much worse than this integral, right? So here you have only x, here you have x squared by 2. So let's choose it the other way around. Now I'm going to choose df by dx to be my trigonometric function. Suppose this is sine of x. So I'm going to use this matrix. I'm going to use this matrix so that it is easier for me to write this formula here, right? Then g, I'm going to choose g to be my x, because it will be differentiated. When you differentiate x, you get 1. Okay. Now once you obtain this, you have to find f and dg by dx, because on this side you have f and dg by dx. So how do you obtain f? You have to integrate sine x. If you integrate sine x, it will be minus cos x from standard integrals. If you differentiate x, you get 1. Right. Now we have to write the right hand side. On the right hand side, you have the product between f and g. Product between these two. Product between these two. So x into minus cosine x, that means minus x cos x, minus x cos x, right? Then you have to put minus sign, then integral, Then you have to write f into dg by dx. Next you product this. This is the first step. This is the second step. F into dg by dx. Now dg by dx is 1. You only have minus cos x inside. Right. So we have something interesting here. What do we have? You can bring this in front. So cos x dx. This is the original integral. This is the new integral. Now, what can you say about the new integral? This is the standard integral. One of the standard integral. Very easy. So you can now just integrate x cos x plus this would be sin x. Now we have to add constant if this is indefinite. So this is the final answer. Right. So this is example 1. So I will do another example now. Right. So in this example you have product between x and e to the power of x. X in 2 ways. This is also not given in the table or the listed integrals that you have to memorize. So we can use this technique because it's a product. Now every time you see a product, don't panic and run into integration by parts, because there are certain integrals there are which you can integrate without using integration by parts. You can integrate them directly, right? So we will learn it under integration by reverse chain rule. That's a special technique which is not discussed in the A-level syllabus, but we will do some examples using that as well. That's actually a result from a substitution technique, so we will talk about it under substitution. Right. Again a product. Now what to choose for df by dx, what to choose for g. Now since whatever function you choose for g gets differentiated, so it's easier to use a polynomial there. Now you can't do this all the time. Only you do it only if the second function is integrable. If the second function is integrable and it is associated with a polynomial, then do it that way. So I'm going to choose df by dx to be my e of x, this function, exponential function, g to be x. Now integrate ex, I get ex back. I integrate, differentiate this, I get 1. Okay. Now write down first, this is first step and this is second. First you have to get the product. So the product is x into e to the power of x. Then you put minus sign. See, first product, then put minus sign. Then f into 1. So that is only ex. Because when you multiply ex by 1, it's just ex back. Right. So look at this. This is also interesting. Okay. So when you integrate ex, the standard integral, that is ex. Right. So you have to put integration constant here. This is an arbitrary constant. Right. So this is the second example. Right. Third example. Integral of natural logarithm, right? So was there a function when you learn differentiation, was there a function on being differentiated produce ln x, right? So we didn't have any functions as such. අපිට එහෙම functions තිබ්බේ නැහැ. differentiate කරාම natural logarithm වෙන function එකක්. So natural logarithm function එක අපි differentiate කරොත් 1 over x වෙනවා. ඉතින් ඒක සාමාන්‍ය දෙයක්. තර මොන function එකක් differentiate කරාමද ln x එන්නේ. ඉතින් එහෙම integral එකක් අපි දන්නේ නැහැ. So I will make an integration by parts. But there's a problem, there's an issue, small issue. Why? You don't see a product here. No products are there. Now what do? No products. But I can make a product there. So suppose if I write 2, I can write 2 as a product of two numbers. 2 into 1. Right? If I want to write 3, I can write 3 as a product of two numbers, 3 into 1. If I want to write sine of x as a product of two things, so I can write sine of x into 1. So I'm going to use this technique here as well. So I'm going to rewrite it again. 1 times ln x dx. 1 times ln x dx. Now, in this case, this is a bit strange here, because now all this time for the last two example I choose polynomial. Now this is also polynomial. 1 is a polynomial because 1 means x to the power of 0. It's a part of a polynomial. We call it a constant especially. We choose this for g because g will be differentiated, and if 1 gets differentiated it becomes 0. Right. But the problem is this: if you choose 1 for df by g and ln x for this, ln x must be integrated. Now that is your problem. You have to integrate ln of x. That is the problem. But when you select it wrong, you end up with the same thing again. That is exactly why we are trying to use integration by parts. Now in this case, I'm going to change it. How do I change it? I'm going to use 1 to be my df by dx because I can integrate 1, and g can be differentiated, right? ln x, you know how to differentiate this function. Now what you get when you differentiate ln of x? You get 1 over x. When you differentiate ln of x, you get 1 over x. When you integrate 1, you get x, right? Now write f into g, this one first, f into g, x into ln x, x ln x. Then you put minus integral f into dg by dx, right? So x into dg by dx is 1 over x dx. Now what happens is that this x cancels out this x, so x times ln x minus integral of 1 dx. Integral of 1 dx. So what is integral of 1? Integral of 1 is just x plus constant c. So this is the integral of ln x. See, this technique is very beautiful. Right, so this is the final example, and this is a very important one because in this example you will have to use integration by parts twice, right? So I name this integral I. There's a reason for that. You will learn that soon. Product between an exponential and trigonometric function. Exponential and trigonometric function. Now we know when you differentiate exponential, you get exponential. When you differentiate sines, you get cosine. When you differentiate cosine, you get sine. So that is oscillating. Sine, cosine, cosine, sine. Exponential goes to the same thing. When it comes to polynomials, when you differentiate polynomials, the exponents gets deducted, and finally they will be taken out of the integral, right? So for example, if you differentiate x, you get 1. If you differentiate 1 again, it will be 0, right? So dealing with polynomials is easy, but when you have a product between a trig and exponential, that's a bit difficult, right? So let's see. Now in this case, it doesn't matter what function you choose. It doesn't matter what function you choose for df by dx. Suppose df by dx is e to the power of x and g to be sine x, right? Then on integration, you get e to the power of x back. Sine x differentiated, you get cosine of x, right? So let's write I. Let's write I. Okay. First the product. Ex into sine x. So notice here in this case, this function does not change, right? It does not change. Ex into sine x minus integral this product, right? Ex minus, sorry, no minus there. Ex cosine of x dx. Now you see why, right? So when you use integration by parts, nothing happened. It's the same thing. Coupling lipatunin nahi, coupling because you started with a similar integral. The only difference is instead of sine you have cosine. Then remember that. දැන් අපිට මෙන්න මේ ඉන්ටිග්‍රල් එක අපිට ඉවැලුවේට් කරන්න ඕන. මේකටත් අපි ඉන්ටිග්‍රේෂන් බයි පාර්ට්ස් දානවා. මේකටත් ඉන්ටිග්‍රේෂන් බයි පාර්ට්ස් දානවා. මේක මම වෙනම ලියා ගන්නම් j කියලා. Let me write it as j, right? So j is ex integral cos x dx. Okay. Now I'm going to use integration by parts for this. तर මේකෙදි හොඳට මතක තියාගන්න මේ වගේ තැනකදී අපි ex df by dx වලට choose කරා නම් ඒ විදිහටම මේ selection එක තියෙනවා මාරු කරගන්න එපා. මාරු කරගත්තොත් lady ex එහෙමම තියෙනවා. I'll leave it as it is. Then for g I use cosine of x. On different integration this becomes ex. On differentiate this becomes minus sine of x. Okay. So now product, so ex cosine of x, ex cosine of x minus integral ex minus sine of x, integral minus sine of x dx. Okay. So let me write just one more step. Ex cos x, this becomes plus ex sin x dx. Okay. Now what you see here is that this is the integral you started with. This is the original integral, right? So I can name this I. I can name this I. Ex cosine of x plus I. Plus I. Right. Now I'm going to plug this back here. Because this is j, I'm going to plug this back here and let's see what we'll have. So let me use a different color for that. Okay. So let me plug this back in. This is an intermediate step, so I will separate it out. Intermediate step. So now I is equal to ex sin x minus this guy ex cos x plus I. Ex cos x plus I. Now so this is equal to ex sin x minus ex cos x minus I. This will be minus I. Now you can see that I is on left hand side, there's an I on the right hand side. I'm going to bring this over here. Then this would be 2 times I. So I get 2 times I, the integral. 2 times I is equal to this. So let me just take e to the power of x. So sin x minus cos x. Right. So now I can divide this whole thing by 2. Right. So I finally have to add integration constant. See how you obtain. This is what you started with. This is what you wanted to integrate. Now we just integrated. Now you integrated this function. See. So මේක තමයි උපරිමයෙන් මේනවා නම් එන්න පුළුවන්. ඉතින් මේවා ගණන් කරගන්න පුළුවන්. මෙතනදී integration 5 parts දෙපාරක් දාන්න. හරිද? එතකොට අපි මේ වගේ ගණන් ටිකක් කරමු ක්ලාස් එකේදී. So until then, see you.